In chapter 15, we're still talking about probability, stuff you guys have done before, just more complex problems. Chapter 14 is pretty straightforward. And so chapter 15 talks about more complex scenarios. Again, we're just going to do this in little pieces. And so today we're just going to talk about a rule, and then we're going to talk about using Venn diagrams. And then we'll be done for today. All right, so here's the example used in the book. So I kind of have to read it because if not, we can't follow what's happening. And it's a really important illustration here, okay? So it says, pull a bill from your wallet or pocket without looking at it. An outcome of this trial is the bill you select. And the sample space is all the bills in circulation. So the possible bills are a $1, $2, $5, $10, $20, $50, or $100 bill. Okay, that's what the possibilities are. Okay. Now it says, look at the bill in your hand. There are images of famous buildings in the center of the backs of all but two bills in circulation. The $1 bill has the word one in the center, and the $2 bill shows the signing of the Declaration of Independence, but the rest of them have a building. So it says, what's the probability of randomly selecting a bill with an odd numbered value or a bill with a building on the reverse? Now in chapter 14, when we had or, then we were talking generally about disjoint events with no outcomes in common. But in this case, when you have a bill with an odd number value, that can only be 1 or 5. If you're looking at bills with building on the reverse, it's all of the ones except for the $1 and $2 bill, so 5, 10, 20, 50, and 100. And so we can't just add the probabilities because $5 is in both of those groups. All right, so now I have an overlap. So these events are not disjoint. Right? They have outcomes in common. So we can't just add things together all the time because we feel like it. All right? So since they're not disjoint, we need a new probability rule. And it's really the same rule that you had before. It's called the general addition rule. And it just says if you're trying to find the probability of some event or some other event, then you take the probability of the first event and you add the probability of the second event, but then you subtract the overlap or the intersection if you want to talk about it correctly. That makes sense. Right? You add the two probabilities and subtract out what they have in common. This formula is on the AP Stats formula sheet. It's the first one in the probability section. It's written just like this notation and everything. So anytime you're trying to do the probability of something or something else, you should look at this formula. It would have worked for every single one of the or questions in chapter 14, because in chapter 14, if you have something or something else, there was no overlap, so you would subtract 0. So it would still work. All right? So this formula will be important to you in those events. It's going to be there in front of you on your tests and your quizzes. So if you can use it, then do so. All right? That's going to be one option for what we're going to do today. We could use this rule. The other option is going to be to make a picture, which I think is much easier. All right? But questions about this concept of having to subtract out the overlap? All right. Then I'm going to do an example. And then I'm going to give you the assignment. So back in chapter 1, we suggested that you sample some pages of this book at random to see whether they held a graph or other data display. We actually did just that, and we drew a representative sample and found the following. So they did not look at every single page in the book. They just looked at a sample of pages. And it says that 48% of pages had some kind of data display. 27% of pages had an equation. And 7% of pages had a data display and an equation. All right? So obviously there's some overlap. The first part of this says to display these results in a Venn diagram. All right? I think for the problems I'm giving you tonight, it's very easy to do the problems with a Venn diagram instead of trying to do them using formulas and trying to figure things out. That's just my personal opinion because I hate probability. So if I was going to make a Venn diagram, you would take the percentages from each of the groups and you would subtract the overlap from both of them. if you're going to make a Venn diagram. So 48% minus 7% is 41%. So 41% of the pages in the sample had a data display. 27 minus 7 is 20%. So 20% of the pages had an equation. And 7% had both. That obviously doesn't add up to 100, though, right? 41% plus 7% is 48% plus 0.2 is 68%. So then there's a lot of pages then that don't have data displays or equations, which is, if you looked in our book anytime recently, there are a lot of pages with just words, right? So what's 100 minus 68? 32. So there's 32% left over of pages that don't fit into those categories. All right. Now that I have a Venn diagram, I think it's super easy to answer the questions they're going to ask you. Again, if you don't make a Venn diagram, then you have to do it based on formulas. All right. So I'm going to answer the questions B and C. I'm going to add one in because it's like your homework, and I want to make sure everyone understands. It says, what's the probability that a randomly selected sample page had neither a data display nor an equation? 32%. So you already did the Venn diagram. We already worried about it, right? If you had it in the Venn diagram, you'd have to have gone back and done all that, but we just did. You had to do 48 minus 7 and 27 minus 7, and then you have to add them all together and then subtract from 100. You have to do all the stuff we already did. But now it's from a pretty little picture, and I can just answer the question, right? On C, what is the probability that a randomly selected sample page had a data display but no equation? %. Data display, no equation. That one wouldn't have been so hard about the Venn diagram. You just do 48 minus the 7 because you subtract the overlap out. But again, it's already in my nice pretty Venn diagram, so I don't need to worry about it. Right? Now, I'm going to add another question because our book asks these questions for the homework. What's the probability of getting a data display or an equation? Now, there's two ways to do this. One, use the Venn diagram. If you have a Venn diagram. If you don't make a Venn diagram, you can't use it. If you made a Venn diagram in this context in chapter 15, or means one or the other or both. Okay? So or means all of these added together if you're using the Venn diagram. Does that make sense? So we would have, what was that, 68% earlier? Yeah? If you didn't use the Venn diagram, totally fine. This would be the scenario where you use that general addition rule. Data display or equation equals the probability of the data display plus the probability of getting an equation page minus the probability of both. That's what the formula says. Now, if you're doing it with the formula, you don't use the Venn diagram. Okay? Because the formula is taking into account the overlap. We've already taken into account the overlap of the Venn diagram, so you can't do them both because then you're taking into account the overlap twice. Don't do that. So if you're going to use the formula, you would go back to the original numbers. All right? 48% had data displays, 27% had equations, minus the 7% that had both, and you're getting the same value, 68%. Yeah? Okay. Everyone good with that? Questions about using Venn diagrams? Again, personal opinion, I think it makes problems easier. If you don't want to make a Venn diagram, then don't. Figure it out, and that's your prerogative. It's fine. Different learning styles. All right, then